Bismillahirrahmanirrahim, dear students. Hope all of you are fine. So far, we learned about that how oxides are formed, like how period 3 elements react with oxygen and form different types of oxides, including normal oxides, simple oxides, or peroxides. So today we are going to discuss it further, that what are the physical properties of these oxides. So first of all, you should know the name of all the oxides that are. When sodium reacts with oxygen, it forms a sodium oxide. When magnesium reacts with oxygen, it forms a magnesium oxide. So then aluminium oxide, silicon dioxide, phosphor. There are two types of phosphorus oxides, then sulfur dioxides, and then chlorine oxides. And argon is not involved in this on oxides because argon is a noble gas. It never reacts with any other elements because it itself is a stable element. It neither needs to gain an electron nor to lose an electron. So these period 3 oxides are also called as highest oxides. Now, what's the reason of calling them as highest oxide? Because all the elements that are present in this period 3, these all oxides have their highest oxidation state. How? That every element, every animal that is forming an oxide, it's all of the electrons that are present in its outermost shells are involved in the bond formation. It means that, for example, if sodium has a 1 electron in its outermost shell, this 1 electron is involved in the bond formation. Similarly, the chlorine has 7 electrons in their outermost shell. All of the 7 electrons are involved in the bond formation with any other element like oxygen, etc. So, these period 3 elements are also known as the highest oxides. Then, when we talk about the metallic structures of the third period oxides, we have three kinds of oxides. The first one is the metallic oxide, then giant covalent oxides, and the third is the molecular oxide. So, first of all, in metallic oxides, you have a giant covalent structure, giant structures of an ions that forms an ionic compound or metallic compounds. That includes the first three oxides of the first three groups, that are sodium oxide, magnesium oxide, and aluminium oxide. These all are metals, so they forms the metallic oxides. Then as we move towards the group 4, we have a silicon oxide. That is giant covalent oxide. We will later on study all of the related properties, all of the important properties of this according to the structure in our next part. So the first, then we have a molecular oxides. Molecular oxides are formed with the molecules, including phosphorus, chlorine, sulfur. These all, when reacts with oxygen, they form some molecular oxides. It may have one or two types, but actually these are all the molecular oxides because they are formed by the molecules of phosphorus, molecules of sulfur, molecules of chlorine. So next, when we move towards the melting and boiling point, as we already discussed, the melting and boiling point first increases towards the aluminium, then gradually it decreases. So when we talk about the oxides, now we are talking about the melting and boiling point of the oxides, not the individual element. So for the boiling point and melting point of these oxides concerned, it is stated that high melting and boiling point of metal oxides and covalent oxides, they're very high because more energy is required to break these strong bonds. Like as far as there is some metallic oxides, they have a high melting and boiling point because they require a much more energy to break their bonds, including their ionic bond, including their metallic bond. So they have very high melting and boiling point. Next, when we move towards the molecular oxides, they have low melting and boiling point. And why is that so? Because there are weak intermolecular forces that are van der Waals forces of the dispersion forces. So first we discussed that metallic oxides have high melting and boiling point. Why? Because they are strong enough and they need much more energy to require their, they need much more energy to break their bonds. But as compared to the metallic oxide, molecular oxides have very low boiling and melting and boiling point. because they have a weak intermolecular forces. Clear? So next we have an electrical conductivity. In electrical conductivity, none of these oxides conduct the electricity. Why is that so? Because none of the oxide has free electrons, so all are non-conductors. Okay, all of these oxides are non-conductors because they have no free electrons. But there's exceptional case, and that exceptional case is of ionic oxides. Ionic oxides do conduct electricity, but only in the molten state, not in their ionic bond, in which it is forming an ionic bond or a crystalline shape. It only conduct electricity when it is present in the molten state. Again, I clear you that none of the elements are being discussed over here. We are talking about the oxides. हम oxides की बात कर रहे हैं, हम अब individual element की बात नहीं कर रहे. इसीलिए जब हमने उसका melting and boiling point भी discuss किया तो हमने oxides का किया. And what is stated about the melting and boiling point, that all of the metallic oxides have a high melting and boiling point, but as compared to the metallic oxide, all of the molecular oxides have very low melting and boiling point due to the presence of weak intermolecular forces, very weak van der Waals and dispersion forces. So because of these weak intermolecular forces, they have very low melting and boiling point. They are so easy. They need very less energy to break their bonds. But as far as their electrical conductivity is concerned, these oxides don't conduct electricity because they have no free electrons. For the conduction, for electrical conduction, the free electrons is the one most requirement for the conduction of electricity. But as these oxides have no free electron, so they are non-conductors. But only there is an exceptional case, that is that ionic solids, ionic oxides undergo electrolysis, but in the molten state. So now we are going to discuss the structures in the detail, that how they arrange in how what are their geometrical shape, what are the angles present between the elements. So when we talk about the structures in detail, first of all we will talk about the metallic oxide. Metallic oxide, I already explained that metallic oxide includes sodium oxide, magnesium oxide, and the third one is the aluminium oxide. The first here which I'm going to explain is the sodium oxide. As you can see that sodium oxide is Na2O. It is a normal oxide. So there are two sodium ions linked with one oxygen atom. But you must keep in mind that all of the metallic oxide structure is more or less similar to the structure of sodium chloride that you have learned in first year. So in sodium oxide, there are two sodium linked with a single bond towards the oxygen atom. So they form the sodium oxide. Next, as you can see by this cubic structure, that all of the blue atoms are sodium ions, and which are surrounded by the oxygen ions. So when we move further, we observe that what is the structure of magnesium oxide? Magnesium has the double bond with oxygen, ionic bond. It forms an ionic bond. It completely transfers two outermost electron towards the oxygen. Similarly, like the sodium chloride structure, like the sodium oxide structure, we have a magnesium oxide structure, that one magnesium is present in the center, and all of the other oxygen are surrounding this central molecule or atom. So in aluminium oxide, we know the formula that it is Al2O3. There are two aluminium and three oxygen. As you can see in the structure, that one aluminium, on one side it is forming a double bond with the oxygen, while on the other side it is forming a single bond with the oxygen. So this is the main structure of aluminium oxide, that how aluminium is particularly bonded with the oxygen atom. What is the particular arrangement of the elements? So next, when we talk about the giant covalent oxide, that is silicon 4 oxide, it means silicon 4 oxide. 4 means its 4 electrons are participating in the bond formation. So each silicon atom is attached with further 4 oxygen atom. This is your giant covalent oxide. And then we move towards the molecular oxides. Molecular oxides, we know that phosphorus oxide is included in the molecular oxide, sulfur oxide is included in the molecular oxide, chlorine oxide is included in the molecular oxide. So first I'm going to explain the phosphorus oxides. Phosphorus oxides or phosphorus 3 oxide. What are its physical properties? That it is a white solid, it melts at 24 degrees C, it boils at 173 degrees C, its shape is tetrahedron, and 3 of the unpaired p electron of phosphorus is involved in the bonding. As you know that phosphorus belongs to the group 5, but out of these 5 electrons, so it has a 5 electrons in its outermost shell, and out of these 5 electrons, 3 electrons are involved in the bond formation, means that there are 3 unpaired p electron of phosphorus that is involved in the bonding. So next, that is the phosphorus 3 oxide. That is the phosphorus 3 oxide. But now we move towards the phosphorus 5 oxide. As I already told you that phosphorus 5 means its oxidation state is 5 in this phosphorus 5 oxide. It is a white solid. It sublimes. Sublimes means it directly converted from the solid into the vapors. So what is the temperature for its sublimation? It is 300 degrees C. And in this condition, when the phosphorus wants to form phosphorus 5 oxide, it uses all of the 5 electrons of the phosphorus in bonding. So the phosphorus in its valence shell, it involves the 5 electrons in the bond formation with the oxygen atom. And here's the structure of P4O10, that how the orange atoms is the phosphorus, while red is the oxygen. So here all of the 5 electrons of phosphorus in the bonding. Next we have a sulfur oxide. Sulfur oxide, its physical properties includes that it is a colorless gas with choking smell, and this sulfur, again we have two kind of sulfur dioxide and sulfur ट्राईऑक्साइड. आपके पास दो किस्म के सल्फर्स आ जाते हैं, एक सल्फर डाइऑक्साइड आ जाता है उसके ऑक्साइड्स में से, और एक सल्फर ट्राईऑक्साइड आ जाता है. जब सल्फर डाइऑक्साइड की बात होती है तो एज यू नो दैट द सल्फर बिलोंग्स टू द ग्रुप 6. इट हैज 6 electrons in its outermost shell. So, and out of these 6 electrons in sulfur dioxide, 1 electron pair is remain as a lone pair, and while the other 2 pairs are involved in the bond formation with the oxygen atom. So sulfur uses 4 oxygen in the forming double bond with oxygen, leaving 2 electrons as a lone pair. And due to this lone pair, its structure becomes little bit bent because of the repulsion with the lone pair. Then after sulfur dioxide, we discuss about the sulfur trioxide. Sulfur trioxide means 3 oxygens are attached to the sulfur. Now here there is a no lone pair. All of the 3 pairs of the sulfur is involved in the bond formation. Pure sulfur trioxide, white solid, is the white solid with low melting and boiling point. And when you talk about the gaseous sulfur trioxide, in which all the electrons are involved in the body. All the electrons means all the electrons present in the outermost shell. And the simplest of the sulfur trioxide is the trimer. Trimer means S3O9. As you can see over here, that this is the trimer. S3O9 means the 3 sulfur trioxide molecules are joined in the series. But when it becomes a little bit more larger in size, then it's changed its state from the gaseous into the solid. So this is basically the structure of sulfur trioxide, that how sulfur forms a bond with the oxygen. So here you can see that sulfur is bonded with the 3 different oxygen atoms by using a double bond. So this is the structure of sulfur trioxide. Now we move towards the chlorine oxide. As like the phosphorus, as like the sulfur, chlorine is also present in the 2 forms, Cl1 oxide and Cl2 oxide. Cl1 oxide is actually the yellowish or red gas that is present at the room temperature, and the क्लोरीन यूजेस 1 इलेक्ट्रॉन इन बॉन्ड विद ऑक्सीजन। कि क्लोरीन ऑक्साइड, जब पहला आप क्लोरीन 1 ऑक्साइड की बात करते हो तो क्लोरीन का आपको पता है कि वो 7 ग्रुप से बिलोंग करता है, उसके आउटर मोशन में 7 इलेक्ट्रॉन्स हैं, उसको सिर्फ और सिर्फ एक चाहिए गेन होने के लिए, तो उस एक को गेन करने के लिए वो अपना एक इलेक्ट्रॉन शेयर करता है। सो क्लोरीन यूज ओनली 1 इलेक्ट्रॉन एंड बॉन्ड विद द ऑक्सीजन। सो नेक्स्ट, when we talk about the Cl2O7, ठीक है, chlorine 7 oxide, as there is a 7 indicates that here in this compound its oxidation state is 7. So chlorine is the colorless oily liquid at room temperature. Chlorine uses all of the 7 different electrons in bonding with oxygen. That chlorine uses all of the 7 electrons that is present in the outermost shell of chlorine, and it gets involved with the bond formation with the oxygen. And this Cl2O7 is much bigger in size. So next, so far what we have discussed, that what are the oxides, what are their physical properties, including all the metallic oxides, giant covalent oxides, then we have a molecular oxides, and how they are arranged in their in their structure, that how their electron pairs are shared with oxygen and they form a band or a linear what kind of structure. So I hope all the physical properties of oxides are now being cleared. If there's any problem, you can ask me a question. So thanks a lot for the listening.